Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Synopsys. Susantha Wijesekara is going to talk today about putting a common script between implementation and verification. Susantha, typically when you have a front-end implementation, that's done in a different language than in the back end on the verification side of the design flow. What sort of problems has that caused?
So customers have shared their challenges where they have invested a lot of time on creating tickle scripts on their implementation side. Their challenge is to reuse their investments and scripts for static verification. That is their main challenge.
And so the tickle strips are what?
Tickle is a popular programming language among designers. So here I'm going to talk about how we can use tickle for querying design for static verification.
So drilling down into this, what's the disconnect then?
Okay. So designers have been using tickle for querying designs for creating custom scripts and custom checks. So we want to reuse their investments that they have created around design compiler and primetime for implementation for static verification. For CDC and lint verification, this capability was not there previously because these databases were not available for users. So with VC Spyglass, we want to resolve that problem.
So what's the concern here? Is it time? Is it confidence in the design? Is it the fact that you're going to get a better chip out the door more quickly? What's your driver here?
Basically, customers has already invested a lot of time and effort on setting up tickle scripts and flows in their methodologies. So if customer wants to reuse that scripts or investment that they have done for static verification, that will benefit for them and they can save a lot of time with that.
So why don't you draw this out for us?
Okay.
Susantha, what are we looking at here?
Okay, here we are looking at a typical design compiler script. So what we are explaining here is you can reuse the same design compiler script that you have already built in your flow for static verification using VC Spyglass. If you see this script, you will have different commands. You have set search path and you provide the list of path that where you want to read design files and DB files. Then you will set link library with all the DB lists that you want to read in for the design compilation. Then you will have read file command with format, Verilog or whatever with the list of design files. Then you will source your SDC file. So this is a common set of commands that you have for design compiler script. For static verification using VC Spyglass, you don't need to change anything in this script. What you have to just add is check CDC and check lint command at the end. So once you add these commands, you are fine with the script to use in VC Spyglass for static verification.
Does the team makeup that would be doing these two different functions change at all? Is it still the same? You have design engineers on the front end and then you have verification engineers on the back end, or are you now combining them to the point where somebody can do both?
Yeah, so I think even for design engineers, if they can add just this check CDC command and check lint command, so they can compile the design and run VC Spyglass for CDC and lint verification.
So really what you're doing is you're enabling shifts left, right?
Yeah, that's exactly correct.
Let's drill down into this a little bit more.
Yeah, so in design compiler script as well as primetime script, you will be using a lot of SDC files. Some SDC files may be much complex. So we are going to talk about some SDC commands that we have in primetime. So you will have typical commands like create clock and set clock transition. In create clock command, you can define the clock using get ports. You can use get ports tickle command to define the clock on top level port. As well as in set clock transition command, you can specify the clock using get clocks. So clock is you have already defined, using get clocks you can get that clock. So this is typically a tickle command, non-SDC command. you will have multiple non-SDC commands as well in these SDC files, like get clock transition.
Where has this typically been a problem? Is it the older nodes, or are you really finding that this is a big problem at the newer nodes because you have so much to verify and so much to implement up front?
Yeah, so you will have these SDC files a lot. You have developed this SDC file a lot. So you have already invested time. So why do you want to change that file? So rather than changing, you can use same exact SDC file for static verification as well with Spyglass, VC Spyglass CDC.
So once you've perfected this, you don't want to reinvent it in a different language.
That's correct.
What does this do in terms of time to sign off, time to market? How much can you actually save by doing it this way?
Yeah, by doing this, so if you want to change something in your flow, right, it will take like more time, and you might need to re-verify what you have changed. That will take a lot of time. So you can save that time by reusing same scripts that you have already developed. So you will save a lot of money as well with that.
Why did this take so long to happen? You would think that you'd want a common language between the two. Was it because they developed independently and then now you're just tying it together?
Yeah, so that's what we are talking about here. So you have already developed something for implementation. Why you change that for verification? So you reuse the same thing with VC Spyglass for static verification as well.
Typically with the software, there's a formula that says for every number of lines of code, you're going to have a certain number of errors. You're going to have a fairly standard error rate. Is that the same here, and does this help reduce that error rate?
Yeah, that can happen with Tickle as well, right? It's typically a programming language. When you write a programming language, there can be errors in the code, like regular software, right? So if you are rewriting some Tickle script, there can be a lot of errors, right? That you have to fix it, and then there are multiple cycles to get that cleaned up. So rather than writing again the same similar script in a different way, you can reuse the same script without changing anything. That's what we are doing here.
Susantha, what are we looking at now?
Okay, so we are just looking at a simple CDC crossing where source is at C1 and C2 clock and destination is at C1 and C2 clocks. If you see, source and destination both at same clocks. So if somebody wants to get or filter out these crossing in the design, so sometimes you will have to request this kind of feature from R&D. But if you are in a critical project, a critical timeline, you don't have time to waste. So what you can do is, you can simply create a custom check using Tickle capability that we have built in VC Spyglass to filter out all these crossings. So we have a powerful Tickle command called get CDC paths, which is inbuilt in VC Spyglass. So once you query that command, it will give you a collection of information about this crossing. What is the source? What is the destination? What is the source clock? What is the destination clock? That kind of collection of information we will get from that command.
So really what you're getting to here is you're trying to capture the complicated implementation, which can also include things like dependencies and on-off different modes for all the power domains that are going on in there, and follow the signals across here, and then be able to, without having to reinvent everything, hand it off to the verification guy so they can just pick up where you left off.
Yeah, correct. So this kind of different clock domain crossings, so you can filter out using that Tickle command that I have mentioned previously. So what you just need to do is, you need to get the source, find the source clock, get the sync, and find the sync clock, and just check whether source clock is matching with the sync clock, so that you can filter out all these crossings from the design. So this kind of information you will need, because you might have to review this information with some other teams, because multiple teams are working on same project. So this kind of information you can dump into a report and you can review with other teams.
So how does this fit into the whole ecosystem? What changes?
We have a new product called VC Spyglass. That is the next generation product of Spyglass. So we want to build an ecosystem where all the VC Spyglass users create their scripts, and also from implementation side they already have created scripts. So we need to build an ecosystem where people will share all this information and other people can also get benefited from that.
Susantha Wijesekara, thanks for a great explanation.
Thank you.